This video's attempt is to try to show the connection for parents who grew up learning it the standard algorithm way, or the way we were taught, the way I was taught too in 5th grade, how to do long division with the standard steps, and connecting it with the partial quotients method, which is the way I want students to try it out in class this year. So this video is really for parents and students, but more so for the parents when they want to help their student, and it helps make that connection. It was kind of interesting too, looking at the work today in class, how I saw the parents' work next to the students' work, and just hearing their comments. It was really interesting, and I just want to show you guys they're really connected. They're very similar, and I'll show you how. So on the left-hand side here, I'll show the standard algorithm way, and then over here on the right side, the partial quotients way. Okay, so let's check out, and I'll do it step by step on both. So we have 4,271 divided by 3. This was a problem on last night's homework. Standard algorithm way, or the way we grew up learning it, and I saw it on some of the students' work, how many times does 3 go into 4? 3 goes into 4 one time. 3 times 1 is 3. Subtract, bring down. And you'd be left with this part here. Now, this is exactly what we're doing with partial quotients, except we're looking at the whole number. If you notice, I said how many times does 3 go into 4 one time, subtract, bring down. We're just learning steps. So all we're doing here is memorizing steps. We're not looking at the whole number. So if I look over here at partial quotients, how many times does 3 go into 4,000? Well, 3 goes into 4,000. I can still match up the work. I'm still going to get that 3 there, but that 3, even that 3 over here, that's not a 3, that's a 3,000 that we're subtracting out. That is 3 times 1,000. So if I'm going to take that, I'm going to subtract that out. I'm going to get my 12, and if you notice here, here's my 12, but that's not really a 12 that I have there. If I want to bring down the whole thing, it's 1,271. So stay with me. So now the next step over here in standard algorithm, you would say, okay, now how many times does 3 go into 12? 3 goes into 12 4 times. 4 times 3 is 12. Subtract, bring down. Yeah, but actually, we're asking how many times does 3 go into 1,271? That's the whole number. That's what we want students to realize, is these are whole numbers and not just little parts for a standard algorithm. So we have, how many groups of 3 can we create out of 1,271? Well, we'd still get 4. We'd still get that 12. But that's not a 12, that's a 1,200. That's actually 400 groups of 3. And if I point you out to over here, look, that's not a 4, that's a 400. That's not a 1, that's a 1,000. And we can actually see that in our work over here to the right. That's 1,000, that's a 400. And we're going to subtract, and we'll get 71. And now here you're asking yourself, how many times does 3 go into 7? And you're going to say 2 times. 2 times 3 is 6. Subtract, bring down. But over here, that's a 3 goes into 70. How many times does 3 go into 71? 3 goes into 71. Actually, we'll just keep it easy. We'll match it up with the standard algorithm. We'll say 60, because that's actually what the 6 is over here, is a 60. And that's a 3 times 20. And that's not a 2 over here, that's a 20. And we get with 11. So you can see this still matches up exactly. The exact same amount of steps on both sides, the exact same results, except on the right side they're showing their full work, and they're showing exactly what they're doing in this division problem, how many groups of 3 they're taking out. And now we're left with this 11, and it would simply be the same on both sides. 3 goes into 11 3 times, and you get 2 left over. But we're actually showing what we're doing over here. That's 3 groups of 3 that we're subtracting out, and we're left with 2. And you'd put your 3 over here, and you do your remainder 2. But over here, we're actually counting how many groups of 3 did we create. We created 1,423 groups. Let me write that out. 1,423 groups, and we still have 2 left over. Now, to say that one way is faster than the other, possibly, especially for the adults, because this is the steps, it's just multiply. It's divide, multiply, subtract, bring down. Mommy, daddy, brother, sister, and we learn all these things to memorize it, and we're just learning steps. But over here on the right, if you look, it's the exact same amount of steps. It's not any longer. It's 3,000, 12, 66, a 9, and a 2. It's the exact same amount of work. And over to the right, it shows me they know what they're doing. They can manipulate numbers, they can use powers of 10, and they can determine how many groups of 3 they can create out of 4,271. And then we go back to that age-old debate, well, the left side's faster, who cares about the other stuff? But then here's what I say. As we get older, I don't do long division on paper. I pull out a calculator. So I want students to understand the whys of why this works rather than just to get the answer as fast as possible. And actually with practice, I can get the answer just as fast on the right side as I can on the left side. So even that kind of goes out the window as the more they practice. Now, do I want them? Do I care after a certain point to the right or left side how they solve it? No, I want them to be able to get the correct answer and whatever's going to work for them. But I am asking them right now to use this method to use their number sense, and you can see it's very closely related to what you guys are doing or what we grew up using. All right, so let's try it with one more. So we have 1,950 divided by 5. This was also a problem on last night's homework. Over on the left side, we would say 5 goes into 1 0 times, so we might just go to that 19. 5 goes into 19 3 times. Over here, and we would say 5 times 3 is 15, and we'd subtract, and then we'd bring down. And over here, we could pull out a 15. Oops, it's not a 15, it's a 1500. And how do we get that 1500? Well, 5 times 3, and the 2 zeros, so 300 groups of 5. And there's my 4 again, so you can see there's my 4, there's my 4. And I can bring down my 5, there's my 5. I can bring down my 5 here, there's my 5. I'm left with 45 and 45, but in reality, this is 450 if I subtract out the whole 1500 and not just this piece, which I've done over on the left side. Now, if I'm on the left side, I would say, okay, if I know my facts, 5 times 9 is 45. So 5 times 9 is 45, and I would subtract and bring down. Now over here to the right, 5 times 9 is 45. Add a 0, powers of 0, that's 5 times 90. So I have 90 groups of 5 there. So over to the left, you might then say, okay, now 5 goes into 0, 0 times 5 is 0, subtract and you get 0. Now look at this. I got the same answer on the left and as on the right. The right side is actually less work. The right side, the partial quotients way, is shorter than the left side because I've used whole numbers. And I just got to count now. How many groups of 5 did I create? 390. So when we were putting digits up here, it was a 3, a 9, and a 0, and my answer is 390. Over here, though, I've created 390 groups of 5, and I've shown that in my steps. I've shown the full number sense. And that's where we're really going for. So again, we want them to understand the whys and what's happening, and then as they can start to show what they're doing over here, full number sense, I don't mind this way at all. In fact, when we get older, it's going to be calculator anyways. Alright, so I hope this helped. Please continue to help your students. You know, that helps. Please use the videos though to help show the connection if you can. I'm doing it in the classroom. But above all else, you don't have to do any of this. Write a note on their paper and I will help them. I will help them at recess. I will help them at lunch. It's my job, so please don't bang your head against the wall trying to remember long division. But I do hope this video helps you and it shows the connection between the way we grew up doing it towards the crazy way Mr. Nielsen's trying them to do it now. The way you know, that maybe jokingly sounds like the way I'm trying to ruin them in here, but really I just want them to show full number sense.